Here are some practice worksheets on shading Venn diagrams. Before I get started, I'd just like to note that when I designed these work packages, I used mathaids.com in order to generate some of these randomly constructed Venn diagrams. I will put that link in the description. Okay, so let's just start with some of the more basic types. So let's look at number 1 and number 2. So if I was to shade set B, what I would just do is identify set B in my Venn diagram and shade that in its entirety. Now, looking at number 1, this is not B, or the complement of B. So we're going to look at that diagram on the right. So I've shaded B for question number 2. So for question number 1, to shade not B, I'm going to want to shade everything that I did not shade in that other question. So it's going to be everything outside of set B. So that's going to include some of set A and some of the other items that are in the universal set. So that's this region out here, but not in set A or set B. Okay, so that's 1 and 2. Let's go on to some other examples. So this time we're looking at OR. So we're looking at the union operator. So this is A or B. So if you recall, the strategy was to shade what's in the first set, shade what's in the second set, and our solution will be everything that was shaded. So if I shade set A, this is what I get on the left. If I shade set B, so what is my solution? It was everything that is shaded. So this region over here, this region that includes both set A and set B, and this region that includes set B but not set A. So all of those are part of my solution. Now, let's look at a slightly more complicated version of this, one that involves complements and the union operator. So let's take a look at number 5. So we want set A or the complement of set B. So what's this going to look like? Well, set A would be this portion right here. So it's everything that's within set A. The complement of set B. So not B. So B is this set that I'm circling in blue. If I were to shade set B, I would shade everything that was inside of it. So shading the complement of this, or shading not B, would be shading everything outside of that region. So I'm just going to shade this whole thing. So what is my solution? Well, it's everything that has been shaded by either one of these two operations. So it's this portion that was shaded for both A and B. It's this portion that was shaded for A and not set B. And it's this portion on the outside that did not belong to set A or set B. This part, which belongs to set B but not set A, is not shaded. In fact, it's the only thing that is not shaded in this diagram. Let's take a look at one more. So the complement of A or the complement of B. Alright, so the complement of A, or not A. So this is my set A. We're going to shade everything outside of it. The complement of B, well, my set B is the one that I'm circling in blue. So it would be everything outside of that set. And this is the OR operator, or the union operator. So I want everything that was shaded. What was shaded? It's this portion that is in set A, but not set B. This part that's in set B, but not set A. And the part that's in neither of those two sets. The only thing that is not shaded is this portion in the middle. Let's look at one more example of how that would work. So we have A or B, and then we want the complement of the expression A or B. Well, A, so we shade set A. B, we shade set B. So this is A or B. So that is what has been shaded below, but that is not what we are being asked for. We are being asked to find the complement of the expression A or B. So what we really want is everything that was not shaded in the solution to that original problem. So we do not want the solution A or B. We want everything else. So this portion that I shaded in yellow to find the expression A or B is not part of the solution. In fact, everything that I did not shade to get that is our solution. Okay, so I hope this was helpful. We looked at a number of examples involving these sets and their relationships. If you want to generate some examples for yourself with some solutions, you can go to the link in the description for math aids below. Let's take a look at the AND operator this time. So we have A and B, also A intersect B. So you may hear either of those terminologies used. So we shade A lightly. There's my set A. We shade B lightly. There's my set B. And we're only interested in the things that were shaded twice. Everything else should be erased. So this portion in set A was not shaded twice. This portion in set B was not shaded twice. So our solution is to shade the intersection between sets A and set B. So none of the other regions of this Venn diagram should be shaded. Let's look at a problem that now involves both the intersect and the complement. So A and not B. So we'll again lightly shade set A, and then we're going to lightly shade not B, so the complement of set B. So we're looking at this region. And since we're dealing with the AND operator, so the intersect operator, we only want the regions that were shaded twice. So this intersection in the center was shaded with the expression on the left, and all of this shaded region that is not in set A, not in set B, well, that was shaded based on the expression on the right of the AND operator, but not on the left. So what is our result? It is the region that is in set A but not set B. None of these other regions should have been shaded. Let's look at the difference, or the minus operator, so A minus B. So don't forget that you may also see it written like this. Certainly in the textbook for the WNCP course, or the Nova Scotia course, it uses this notation on the top. So what we do is we shade the one on the left, and then we erase the one on the right. So let's start with shading A. And then I'm going to take my eraser and I'm going to erase set B. So let's just lightly color set B in yellow. Everything that I have highlighted that was in set B is going to be erased. So we're going to erase everything from set B. And what we end up with is that this region on the left has been shaded, the part that is only in set A, and none of the other regions are shaded anymore. I just want to make it clear that I put that yellow portion in there just to show how the shading was working. You normally wouldn't color it in and then erase it. So just quickly looking at this example, shade B minus A, so don't forget, could also look like this. So we're going to shade set B, and then we're going to erase set A. So I'll take my eraser and erase everything that's a part of set A, which is this portion that's in the middle. And our final answer is the part that is in set B is shaded, but not in set A. Nothing else is shaded. All right, let's look at B minus the complement of A, or B minus not A. So again, we're going to shade B. So let me shade everything in B. And then we're going to erase everything in not A, or everything in the complement of A. So let's remind ourselves what that looks like. I'm going to circle set A, and the complement of A is everything that is outside of that circle. So we're going to take an eraser, and we're going to erase everything that is not in set A. And for this problem, that would be this portion that was in set B but not set A. So our end result, the intersect between these two is shaded, but nothing else has been shaded. Let's look at a perhaps slightly more complex version of this problem. So we're going to shade not A minus not B. And again, recall, you may see it in this notation as well. So let's start by shading the expression that's on the left. So that is the complement of set A, or that is not A. So we want everything that is not in set A. That would be all of this. And then we want to erase the complement of set B. So let me highlight set B. And we want to erase the complement of that. So we're going to erase everything that is outside of that set. So let's erase everything that is outside of the circled red region. That is everything that is outside of the complement of set B. And we end up with this as our result. So our shaded region is here, the part that is set B but not set A, and none of the other regions have been shaded. All right, finally, let's look at this problem. The expression B minus A, and that expression, we are taking the complement of it. Well, much like other times in mathematics, we're going to look at the things that are inside the brackets first, and then we're going to worry about that complement. So this is B minus A. So we're going to shade the set on the left, and then we're going to erase the set on the right. So we're going to shade B, and now we're going to erase A. So let's erase set A. Okay, so if we were just asked B minus A, this would be our answer. But that is not indeed what we have been asked. We have been asked to find the complement of B minus A, or, if you prefer, not the expression of B minus A. Well, I have shaded the solution B minus A below. We want the complement of that solution, so we want everything else other than what I shaded for B minus A. So this is the complement of the expression B minus A. That yellow part that was shaded for the expression inside the brackets is not part of our solution. Everything else is part of our solution. So this would be what our answer would look like for the expression B minus A and the complement of that expression.